All right, in lesson 65, we're going to talk about what is called overall average. And so far what we know about averages is that to find averages, you take the total and you divide by how many there were. So for example, if in a basketball game, say a player had 4 points, another player had 7, say another player had 2, one player had 1, and say another player had 10. Say these are the 5 players that started the game, and this is what they scored. Well, we add up the points, and we're going to find the average, what the average points scored by each of the players were. And you divide that by how many players or how many objects or whatever you're talking about there were. And here there were 5 players. And you add these up, the top, and you get a certain total, and you're going to divide that by 5. Now that's what we've done with the averages so far. Now sometimes we have situations where we want one of the points, one of the players, or maybe one of the tests, if a teacher is averaging tests, we want maybe one of those tests to be more important or weighted more. So what I'm saying is, let's say that in your science class, say that you've had 3 tests. Now say one of the tests, I'll say they're out of 10 points. Say all these tests are out of 10 points. And one of the tests you had an 8, and another test you had maybe you didn't do so well, you got a 4, and another one you had a 7. Now, say you had these 3 tests in the quarter. So this is the first test that you had in the quarter, then the second test, and the third test. Now, maybe the teacher wants that third test to count more. And he or she may have their reasons for that. Maybe they want that third test to count more because it was more important material, what they feel. Or maybe you spent more time on it. Maybe you spent half the quarter preparing for that third test, and the teacher wants that to be weighted more. Well, here's how we would do this. Say that the teacher wants the first test to be weighted at 1, and I'll explain what that means a little bit. Maybe the teacher wants the second test of the quarter to be worth double, and maybe that third test is worth triple, right? Now these are what we would call weights, all right? Now the teacher wants the first test just to be normal, just a regular test, so a weight of 1. He or she wants the second test to be weighted double, and they want the third test to be triple, for whatever reasoning. Now, this is what we do, and then we divide by the weights, the total of the weights. Well, the total of the weights here, 1 plus 2 plus 3 is 6. Now, obviously, which test is carrying more weight? Well, it's the third test, but if you really look at this, these 2 tests are carrying a lot of weight because they have a weight of 5 out of the 6 possible weights. So let's see, 1 times 8 is 8, plus 8 plus 21. Now in this particular example, and I'm going to use a calculator on this, you add those up now, you take the total just like you normally would, and then you divide by 6. So I'm going to do that right now. So you've got, let's see, a total of 21 plus 16, so we have 37 divided by 6, which gives us about 6.17 if I rounded that. So does that make sense? And it does make sense because this test you didn't do so well, and that test was worth double. And then this next test you did a little better, so your score is going to be between 4 and 7, in which it is, and it's closer to 7 because you did pretty well, or you did better, I should say, on that third test. So this is what we mean by overall average. Now let's take a look at another example. Okay, in example 1, it says Jim's scores were 60, 70, 80, and 90. So maybe these were scores on a test. So on one test he had a 60, another one 70, another one 80, another one 90. Now what is the weighted average of his scores if the tests were weighted 1, 2, 4, and 6 in that order? All right, so the first test is weighted at 1, so that's 1 times 60. So it's just a normal test. And then the second test is doubled, or a weight of 2. And then the third test, it's worth 4 times as much as a normal test. So 4 times 80. And finally, the last test is 6 times a normal test. So 6 times 90. Now, what's the total of the weights? We'll add those up, and we get 13. Now, we're going to get a total now on the top. So we're going to multiply. So you have 60 plus 140 plus 320 plus 540. And we're going to divide that total by 13. All right? Now, before we even do this, let's think about a reasonable answer on this. If I were going to, which test is carrying a lot of weight? Well, it's this one, right? Because it's 6 times as much. And even this one's carrying pretty good weight. So these scores, this 80, your score of 80 and 90, which were your higher scores, are really going to pull these scores up. Now, let's see if that happens. So we got 60 plus 140 plus 320 plus 540 gives me a total of 1,060. And I'm going to divide that by 13, and let's see what we get. And I'm going to have to round it a little bit, so approximately equal to 81. I'm going to round it to 2 places, 54. So his overall average was 81.54, and that makes sense. So it's a little closer to this one than this one. Now why? Well, because these are kind of pulling this score down a little bit. So our answer makes sense. All right, let's take a look at example 2. Test scores again, 70, 80, and 100, with the weights of 1, 5, and 7 in that order. So what's the weight of the 70? Well, 1. What's the weight of the 80? 5. So 5 times 80. So that test is worth 5 times as much. And what's the, say they got a perfect, say this test was out of 100, and they got a perfect score. And say that particular test is weighted 7 times as much as a normal test. Well, we're going to add these up, and what's the total of the weights? What's 1 plus 5 plus 7? 13. So I have 70 plus 400 plus 700, and we're going to divide that by 13. So let's total the top. So I have 1,100, so 70, and divide that by 13. Okay, so I have 1,170 divided by 13, and I get 90. Now, I can check this to kind of see if I did this correctly. Does 90 make sense? So you had kind of a low score, kind of had an average score, but notice we ended up with a fairly high score. Well, that's because this test was worth so much and you did so well on that, or this person did so well on it. So it makes sense. All right, example 3. Now, I'm not going to go through this whole thing, but I am going to set it up. You've got a test that was worth 75, another one worth 80, another one worth 88, and another one worth 93. What's the 75 worth? Well, 1. So 1 times 75. What's the score of 80 worth? 2. What's the score of 88 worth? 3. That one's worth 3 times as much. And how about that score of 93? If this were out of 100, that's worth 4 times as much. It was weighted at 4. Now you're going to multiply first and then add them up and then divide by what total? We'll divide by how many weights there were. 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. And when you get this total, it's going to be easy to divide by 10 because all you have to do is move the decimal point 1 place to the left. I would, if I were you, I would finish this one out to see what you get. All right, last example. This one's a little different, not much. In the graduate level course Smith was taking, each of the 3 tests were weighted 20%, and the final paper was weighted 40%. So let's see, the weights were 20%, 20%, and then you actually had a third paper that was weighted at 40%, because it's a final, so it's worth more. Now it says this scores, it gives us scores, but this time it doesn't give scores in just normal points, it gives them in percents. So here's his scores, 60%, and then a 70% on the second paper, and finally on his last paper, his most important paper, he had 80%. So again, this is a little different from the other examples because it's not giving the test scores in points, it's giving them in percents. Now what was the first one What was the first one weighted at? Well, it was weighted at 20%. Now the second paper was weighted at 20%, and then the totals of the two were, and I should say the final paper was weighted at 40%. Now what you're going to do is you're going to add these up, which is going to be a little different here, and then we're going to divide by the total of the weights. 20 plus 20 plus 40. Let's see, 40 and 20, so that's 80%. So you're going to divide by 80%. Now, what do you do with percents when you're dealing with percents? You have to change them to decimals. So let's see, 2 places left, so I got a 0.2 times a 0.6, right? Plus a 0.2 times a 0.7. Remember to change a percent to a decimal, 2 places left. 0.4 times a 0.8. And finally, you're going to divide by 0.8. Now, before you get an answer on this, or before you do this, let's try to make a prediction what my score is going to be, or what would be a reasonable score. Did pretty well on that final paper, and that final paper was worth just as much as the other 2 papers combined. So I'm going to guess between 70% and 80%. All right, let's see. So I'm going to get the calculator out, and let's see what we get. So we got a 0.2 times a 0.6 gives me a 0.12, plus 0.2 times 0.7 gives me a 0.14, plus 0.4 times 0.8 gives me a 0.32. And then we're going to divide by 0.8. So 0.32 plus 0.14 plus 0.12 is 0.58 divided by 0.8. And I get rounded, let's see, rounded I get 0.725. Or turn it back to a percent, change the decimal back to a percent. That's 72.5%. So I was pretty close. All right, so just the overall score that this person got for the 3 papers was a little bit beyond the 70%. Well, why wasn't it closer to 80? Because this brought the person down a little bit. So on these type of problems, you do them the same way. You just got to make sure you change the percents to decimals. And then in your final answer, change it back to a percent again. So our topic was called overall averages.